All right, so Meta just launched Muse Spark, what they're calling the first in the Muse family of models developed by Meta Superintelligence Labs. They say Muse Spark is a natively multimodal reasoning model with support for tool use, visual chain of thought, and multi-agent orchestration. Muse Spark is available today at Meta.ai and the Meta AI app. We're also making it available in private preview via API to select partners. And we hope to open source future versions of the model. Very interesting that they're stating that. But this just goes to show that AI is continuing to advance, and these companies have to keep producing and keep pushing products forward to production level. So let's get into the docs here. On this channel, I love reading the docs. Hopefully you'll love listening to me read the docs. Introducing Muse Spark, scaling towards personal super intelligence. Today, Meta said we're excited to introduce Muse Spark, the first in the Muse family. Let's get a little close up here. Of models developed by Meta Superintelligence Labs. Muse Spark is a natively multimodal reasoning model with support for tool use, visual chain of thought, and multi-agent orchestration. Muse Spark is the first step on our scaling ladder and the first product of a ground-up overhaul of our AI efforts. To support further scaling, we are making strategic investments across the entire stack, from research and model training to infrastructure, including the Hyperion data center. Muse Spark is available at Meta.ai, like I said before, and is private preview for right now. So, capabilities for personal superintelligence. Muse Spark offers competitive performance in multimodal perception, reasoning, health, and agentic tasks. We continue to invest in areas with current performance gaps, such as long horizon agentic systems and coding workflows. With larger models in development, these results demonstrate that our stack is scaling effectively. And then they go over the benchmarks here. I'm not really too much of a benchmark guy, but you can see the numbers here. All these benchmarks to me are subjective in a way, unless you really dive in and do the testing yourself. But I digress. They state we're also releasing contemplating mode, which orchestrates multiple agents that reason in parallel. This allows Muse Spark to compete with extreme reasoning modes of frontier models such as Gemini, DeepThink, and GPT Pro. Contemplating mode provides significant capability improvements in challenging tasks, achieving 58% in humanities last exam and 38% in frontier science research. So again, they have more benchmarks here, as you can see. And here they talk about applications. So Muse Spark is the first step toward a personal superintelligence that understands your world. From analyzing your immediate environment to supporting your wellness, the advanced reasoning capabilities of Muse Spark enable powerful, highly personal use cases. Muse Spark is built from the ground up to integrate visual information across domains and tools. It achieves strong performance on visual STEM questions, entity recognition, and localization. These capabilities come together to enable interactive experiences like creating fun minigames or troubleshooting your home appliances with dynamic annotations. Now imagine troubleshooting your home appliances with AI. Like, come on. One major application of personal superintelligence is to help people learn about and improve their health. To improve Muse Spark's health reasoning capabilities, we collaborated with over 1,000 physicians to curate training data that enables more factual and comprehensive responses. Muse Spark can generate interactive displays that unpack and explain health information such as nutritional content of various foods, or muscles activated during exercise. This sounds pretty interesting to me. And what do they have here? I think this is just like a little demonstration. And you can swipe through this and see some of the stuff that Muse can do. Pretty interesting, pretty interesting. So let's get into this part, scaling access. To build personal superintelligence, our model's capabilities should scale predictably and efficiently. Below, we share how we study and track Muse Spark's scaling properties along 3 axes: pre-training, reinforcement learning, and test time reasoning. The pre-training phase is where Muse Spark acquires its core multimodal understanding, reasoning, and coding abilities. The foundation that reinforcement learning and test time compute build upon. Over the last 9 months, we rebuilt our pre-training stack with improvements to model architecture, optimization, and data curation. Together, these advancements increase the capability we can extract from every unit of compute. The results are clear. We can reach the same capabilities with over an order of magnitude less than our previous models, Llama 4 Maverick. This improvement also makes Muse Spark significantly more efficient than the leading base models available for comparison. What do they got here? Held out code base perplexity. So they state here, after pre-training, reinforcement learning leverages compute to scalably amplify model capabilities. Even though large-scale RL is notoriously prone to instability, our new stack delivers smooth, predictable gains. So the reinforcement learning is really helping Muse here. On the left, we see log linear growth in pass at 1 and pass at 16. So here they show it here. This indicates that RL is improving model reliability without compromising reasoning diversity. On the right, accuracy growth on a held out evaluation set establishes that the gains from RL predictably generalize. Muse Spark smoothly improves on tasks that were not seen in training. Here you can see on the right. So for test time reasoning, RL trains our models to think before they answer, which is becoming a common thing with AI, a process known as test time reasoning. Serving this capability to billions of users requires efficient use of reasoning tokens. To achieve this, we rely on 2 key levers: thinking time penalties to optimize token use, and multi-agent orchestration that boosts performance without slowing down response times. On a subset of evaluations such as AIME, this causes a phase transition. After an initial period where the model improves by thinking longer, the length penalty causes thought compression, and Muse Spark compresses its reasoning to solve problems using significantly fewer tokens. After compressing, the model again extends its solutions to achieve stronger performance. So we can see here that Meta is really trying to advance not only its models, but its place in the rankings when it comes to AI. So they say, to spend more test time reasoning without drastically increasing latency, we can scale the number of parallel agents that collaborate to solve hard problems. While standard test time scaling has a single agent think for longer, scaling Muse Spark with multi-agent thinking enables superior performance with comparable latency. So here we have humanity's last exam and their data here. Now on safety, it says Muse Spark has broad reasoning capabilities across dual-use scientific domains, so we conducted extensive safety evaluations before deployment. Our process follows the updated Advanced AI Scaling Framework, which defines threat models, evaluation protocols, and deployment thresholds for our most advanced models. We evaluated Muse Spark both before and after applying safety mitigations across frontier risk categories, behavioral alignment, and adversarial robustness. We found that Muse Spark demonstrates strong refusal behavior across high-risk domains such as biological and chemical weapons, enabled by pre-training data filtering, safety-focused post-training, and system-level guardrails. In the cybersecurity and loss of control domains, Muse Spark does not exhibit the autonomous capability or hazardous tendencies needed to realize threat scenarios. Our evaluations show Muse Spark falls within safe margins across all frontier risk categories we measured given its deployment context. So safety is going to be a big part of AI models now and going forward in the future. And that is why we see Meta focusing on it. So they state, in conclusion, with Muse Spark, we're on a predictable and efficient scaling trajectory. We look forward to sharing increasingly capable models on the path to personal superintelligence soon. So it's interesting to see these companies come out with these new models, pushing the limits, pushing the capabilities forward. This is just yet again another example here with Meta. And they've dropped Muse Spark. So the real question is, how is this going to play out? How well is this model going to perform? And what comes next after this model? As we're on the age to, like Meta says, superintelligence and potentially AGI. Let me know what you guys think about this video. If you like this video, subscribe. If you want to see more content like this, subscribe. If you have any content recommendations, let me know down in the comment section below.